So, hi guys, welcome to my video tutorial. I am Marky Carpio and today I am gonna be discussing to you some topics under integral calculus and what is integral calculus. So, ano nga bang mga topic na i-discuss ko? Una is the logarithmic integration. Pangalawa is the trigonometric transformation. Pangatlo ay ang inverse trigonometric integration. At ang panghuli ay ang integration by parts. Also, we will gonna be solving some problems under each of those topics later on. But before that, we will first understand what is integral calculus.
Integral calculus is a branch of mathematics which involves finding the accumulated area under a curve represented by a continuous function. It complements differential calculus, serving as its inverse.
So ngayon, naintindihan na natin kung ano ang integral calculus. In simple terms, integral calculus, ito ay may kinalaman sa paghahanap ng accumulated area under a curve. So example, we have a curve here. So, hinahanap natin ito. So, that is when ang integral calculus ay pumapasok. Also, integral calculus, it is the inverse of the differential calculus. So, just to remind you guys, the integral calculus has a relation with differential calculus, also with trigonometry, algebra, analytic geometry, and many more. So, if you did not have yet undergo with those lessons, I suggest that aralin nyo muna ang mga lesson na yon. Kasi, as we go on to our topics, this will get harder and harder. And those things, magiging useful yun sa ating mga pag-aaralan mamaya. So, therefore, if hindi nyo pa alam ang mga bagay na yon, kailangan nyo munang aralin yon. So, that's it. Now, let's move on to the standards formula that we will gonna be using when we encounter the problems later on. So, and also when we solve those problems. So, these are the standard formulas that we will gonna be using. Just fix this off. Here. So, first, we have this formula. So, our first formula, just write this down. We have this first formula, the integral of x dx is equal to x raised to n plus 1 over n plus 1 plus c. So, we just make this clear. You have this formula. So, ang formula na ito ay tinatawag kong the inverse power rule. So, do you still remember the power rule in the differential calculus? Diba, yung power rule is nagsusubtract tayo ng 1 sa differential calculus. Example, we have this x raised to n dx here. So now this will result to x raised to n minus 1. That is in differential calculus. But here in the integral calculus, mag-a-add tayo ng 1 sa exponent. But it's not only that. We will also be dividing this here sa exponent plus 1 plus c also. So this plus c here represents an unknown constant that may be present to our original equation. So, sa integral calculus, dapat kung mag-integrate ka, is hindi mo dapat tanggalin tong constant na ito or plus c. Because, to check if our answer is right, we have to derive this. And the derivative of this constant will be 0. And if we derive this, we'll just what's this? We'll just follow the power rule in the differential calculus. Subtract 1 to the exponent and we will get that. For example, we have the integral of x raised to 4, or the antiderivative of x raised to 4 dx is equal to what? So now this will become x raised to 4 plus 1 over 4 plus 1 plus c. So this is now 1/5 x raised to 5. So to check if our answer is correct, so we have to derive this. And if we get the answer, which is this, then we are right. So now, let us derive. So to derive, we have 1/5 here. So this exponent, we have to multiply this or move this here, which this will become 1/5 times 5, then x. Then this, we have to subtract that and by 1. So now, this will cancel out. This will now become 1 only. So now we will only have x raised to 4. So now, this is the same as that. So we are right in our solution. So that's for the inverse power rule. Now, let's move on to our next formula, which is this. Number 2, the antiderivative of a dx is equal to ax plus c. So, paano nangyari yan? So, this is just similar to the inverse power rule. The way we can integrate this is we just add x or add x next to this constant. So a here is a constant. Remember that a here is a constant. That's a constant. So to derive that or to integrate that, we just have to put x next to that and add c. So why? Because you know in the power rule we add 1 to the exponent, right? So we can see this ax as a dx as ax raised to 0 dx, the antiderivative of ax raised to 0 dx. So we know that x raised to 0 is equal to 1. So therefore this will become a dx only. So that is the same, right? So therefore we can use that, and we have to apply the power rule formula. So therefore meron na tayo ngayong ax raised to 0 plus 1 over 0 plus 1 plus c. So now, ito ay magiging ax. So we don't have to put 1 here since it's kwan na siya. Ganyan na talaga siya. So always one exponent, there's always one exponent here if it's not visible. So 1 plus c. So anything that is divided by 1, so that's still the numerator. So ax plus c. So that's how we came up with our answer, the ax plus c. So remember, this is applicable when we have a constant, here, constant only. So example, we give you some example. We have the antiderivative of 12 dx. So this will now become, mag-add lang tayo ng 1 sa tabi ng x rather, sa tabi ng 12. Therefore our answer will be 12x plus c. That's it. Simple. Now, next is our third formula. Just erase this. Our third formula, which is the antiderivative of the quantity ax of ax plus b raised to n dx is equal to 1 over a times ax plus b, just erase this, x plus b, n plus 1 over n plus 1 plus c. So this is similar to power rule also. The only difference is that nag-multiply tayo ng 1 over a dito. So this a here is the derivative of what's inside this parenthesis. So this is applicable on linear functions. So now let me give you some example. We have the antiderivative of 9x plus 2 raised to 3 dx. So anong mangyayari? We just have to follow this formula. So 1 over the derivative of what's inside this parenthesis. So what's the derivative of this? So this will become 9 only, since derivative is we subtract 1 to the exponent, right? And the derivative of a constant is 0. So therefore this will now become 9 only, times the quantity of ax plus 9x plus 2, 3 plus 1 over 3 plus 1 plus c. So now this will become 4, right? So 9 times 4, we have 1 over 36 times 9x plus 2 raised to 4, since 3 plus 1 is 4 plus c. So that's our final answer. That's how we perform this formula. So now let's move on to our next formula. Let me just erase this. Let's move on to our next formula. We have this number 4. The 1 over x dx is equal to ln x plus c. So tinatawag ang formula na ito na logarithmic formula, since you remember that in differential equation or differential calculus, when we derive ln x, example, you have d over dx ln x, the derivative of that is 1 over x. Therefore, since in integral calculus is just the inverse of the differential calculus, therefore 1 over x dx is equal to ln x plus c. The difference is that we put plus c at the end, since that represents a constant that may be present to the original equation. So now let me give you some example. So we have 7 over x dx is equal to what? So notice that we have 7 here and we only have 1 here. So para ma-convert natin siya sa ganito, so ilabas natin yung 7. Ilabas natin yung 7 sa integral sign. So now ang matitira na lang ay 1 over x. Since 7, pag ibalik natin siya sa loob, 7 times 1 over x is just also 7 over x. So dx. So now pareho na. Ito at ito ay magkapareho na. So gamitin lang natin ang formula. So ibalik natin to sa loob, 7, then insert the equal of 1 over x, the antiderivative of 1 over x, we have the ln x plus c. So that's our answer for this example. Now we have to move to our fifth formula. We have the antiderivative of e raised to x dx is equal to e raised to x plus c. So Ang formula naman nito ay ang exponential formula. So, in differential calculus, pag diniderive natin ang e raised to x, this is just also equal to e raised to x. Since the formula for that is e raised to x is equal to e raised to x times the derivative of the x, the x prime. Since the derivative of x is just 1, therefore e raised to x times 1, this will become only e raised to x. So therefore this is still the same. So if we also integrate e raised to x, this will just become e raised to x plus c. So don't forget to put plus c at the end. So I guess we don't need example for this one, since this is just an easy one. Now let's move on to our sixth formula. So e raised to x, ex plus b is equal to 1 over a e raised to ax plus b plus c. So now, sorry, dx. So paano to nangyari? So this is also the same from the exponential formula, and para siyang combined na exponential formula and this formula. So the difference is that in exponential formula we only have x exponent, right? But here, this formula, we have a linear exponent. Therefore, we have to multiply e raised to ax plus b to 1 over the derivative of this linear function, 1 over a, since that is a linear function. So the derivative of ax plus b is just a. So let me give you some example. We have example is the antiderivative of e 7x dx is equals to 1. Wait, let's solve first. So this here is still a linear function. So if we integrate that, this will become 1 over, wait, we just try to, well, 1 over the derivative of this is 7, since we will subtract the exponent with 1 if we have to derive. So 1 over 7 times e raised to 7x plus c. So that's our answer. Simple as that. Now we have to move on to our next formula. We still have formulas left. Just get this off. So I hope you have take note of those formulas, since we will gonna be using those as we go through our discussion, as we go or as we dig deeper to our discussion. So now let's move on to our seventh formula. We have here 7 formula. Wait, let me just write this down. 7 formula, which is the antiderivative of sine x dx is equal to negative cosine x plus c. So as I said earlier, so integral calculus has a relation with the differential calculus. So we know in differential calculus that the derivative of cosine x is negative sine x. So since we don't have a negative sign here, therefore our answer here will become negative cosine x, and also we will add c at the end, since we are in integral calculus. That's just how we integrate sine x dx. So always remember these formulas, since these formulas will be helpful, especially in trigonometric transformation. So now let's move on to 8 cosine x dx is equal to sine x plus c. Now in differential calculus also, pag i-derive natin yung sine x, ang magiging result niya ay cosine x. Therefore, since the integral is the inverse of differential calculus, so if we derive this, ang magiging result niya ay sine x. If we derive cosine x, simple as that. You just have to remember your lessons in the differential calculus. So that's how we integrate the cosine x. So next we have the secant squared x dx is equal to tangent x plus c. Still the same. The derivative of this is this, and therefore the antiderivative of secant squared x dx is tangent x. So remember these formulas. So all of this may relation siya sa differential calculus. So I guess I won't have to explain this one by one, since the process is all the same. You just have to remember the lessons on the differential calculus para makuha mo ang antiderivative ng mga ito. So aside from these formulas that I have given to you, there are still a lot more formulas out there, but hindi na natin yon iisa-isahin because it would take so much of our time. But as we go through our lesson or our discussion, as we dig deeper, may mga bago akong formula na i-introduce sa inyo, sapagkat magagamit natin yan sa pagsosolve ng mga problems under the topics, especially in the inverse trigonometric integration, the trigonometric transformation, and the last part, which is the integration by parts. So now, since I have already given you the formulas, let us move on now to our first topic, which is topic 1, the logarithmic integration. So by the way guys, our set of problems will be categorized to 3 parts. First is the easy, second is the moderately difficult problem, and lastly the difficult. So one problem for easy, one problem for moderately difficult, and 3 problems for difficult. And each topic will have 5 problems to solve. Therefore, we will have a total of 20 problems to solve in this whole discussion. So now, let us know the purpose of logarithmic integration. So logarithmic integration is performed to find the integral of a function that results to a logarithmic expression. So in this topic, the logarithmic integration, we will use the formula, which is this, our formula number 4, which is this: 1 over x dx is equal to ln x plus c. So we'll use this formula: 1 over x dx is equal to ln x plus c. So we can also write this as dx over x. So often, when we use So we know when we use logarithmic integration, when we have a quotient here, our integrand is in a form of quotient. Wait, I erase that since we put this already. So if our integrand here is in the form of quotient, therefore we have a chance to use the logarithmic integration. Also, if nakita natin na yung top ng quotient integrand natin is the derivative of the numerator, then ito na ang time na gagamitin natin ang formula na ito. So pag napansin yung ang top, which is the numerator, is the derivative of the denominator, so ang magiging result nito ay in a form of this, the ln x plus c. So that's how we use or how we perform the logarithmic integration. So now, since we have understand what is the purpose of logarithmic integration and how do we use that, let us now proceed to our problem number 1. So let me remove this so that we can see our problem number 1. Okay. So now that is our problem for the logarithmic integration. So now let us first solve this problem number 1. We just write this. Well, so the antiderivative of 1 over 2x dx. So anong magiging result nito? We know that the formula for the logarithmic integration is dx over x, or we have 1 here, right, is equal to ln x plus c. So this here is in a form of this. So if we multiply this to the top, this will become dx over 2x. So ang pagkakaiba lang is may 2 sa denominator, right? So let me just rewrite this. We can rewrite that as dx over 2x. See? So ang pagkakaiba nila ay may 2 dito sa denominator, but remember may 1 dito, right? So we can move this 1 over 2 outside. So we have, now let us move this 1 over 2 or 1/2 outside. Now ang matitira na lang ay dx over x. So now this is in the form of our formula, which is the dx over x. So now our answer will now become, since may 1/2 tayo sa labas, i-move natin siya ulit sa loob. Then we will multiply this by, since this will become ln x plus c, so we have to multiply that. We will now get 1/2 ln x plus c. So that's our answer for problem, for problem number 1. This is our answer. So take note of our process and take note of the answer so that you won't find it hard if you encounter this problem again. So this is the most basic in the logarithmic integration. This is the easy part of our problem. So now let's move to our moderately difficult problem, the number 2. The antiderivative of 12x squared, wait, 12x squared over 7 minus 4x cubed dx. So remember that the denominator and the numerator is related. So In logarithmic integration, the numerator is the derivative of the denominator. So now, tingnan yung maigi ang problem. So, ito ang sinasabi ko na pag makikinig kayo sa akin is that you must have the knowledge on your previous lessons, which is the differential calculus. Because kung wala kang knowledge sa differential calculus, hindi ka matututo nito. You won't be able to understand even a little bit of this. So, remember, the numerator is the derivative of the denominator. So now, let us try to derive the denominator. So, sa problem na ito, gagamit tayo ng technique which is the U substitution technique. The U substitution is performed like this. So, we let U is equal to the denominator, which is 7 minus 4x cubed. So now, the derivative, which is, this will become du, derivative of u will become du. What's the derivative of 7 minus 4x cubed? So the derivative of a constant is 0. Then, the derivative, the way we derive this is just move this to the front right, then multiply that. Then we will have, since we have a negative sign here, we will put it here. Then 3 times 4, this will become 12. Then when we derive something or a variable with an exponent, we subtract 1 to its exponent, right? So now this will become 12 negative 12x squared dx. So now we will isolate now the dx. So dx will become du over negative 12x squared. So notice that the derivative of our denominator is similar to our numerator. The only difference is that we have a negative sign here. So let's think about that later on. Now let's plug in this dx. Let's substitute this dx, which is, this will become du over negative 12x squared here. Now we will have the antiderivative of 12x squared over 7 minus 4. Wait, this is u now, since we let our 7 minus 4x cubed our u. So this will become u. Then we substitute this to the value of dx here. So du over what? The negative 12x squared. So now, what do? We will now cancel this out, since 12x squared over 12x squared is equal to 1. So now we will cancel this out. Now, since we have negative here, we will just have to move that outside. Ang matitira na lang ay ang du over u. So, du over u is in the form of our formula, which is the 1 dx over x is equal to ln x plus c. So, it's in the form of that, right? So now, we just erase this. So now, we just have to put this, since du over u, the derivative of u and our u here. So we will have just move back our negative sign to inside. We will get an answer negative. What's du over u? Ln x. So now, since we use u, we will have ln u plus c. So is this our final answer? No, not yet. So since we have a value of u, which is, we let u earlier is equal to 7 minus 4x cubed. Now we have to substitute the value of u here. So we will now get ln. So by the way guys, we have an absolute value here, absolute value of x, since we are avoiding negative result here. So the absolute value of what is our u? So we have 7 minus 4x cubed absolute value plus c. Now this is now our final answer. Simple as that. So remember those things that I've done and take note, so that if you encounter this kind of problem ay hindi na kayo mahihirapan pa na mag-solve. So, you just have to remember your lessons on the differential calculus and other form. So now let us move to our difficult problem, the number 3, which is we have the antiderivative of cosine 2 theta over 3 sine 2 theta d theta. So now, how do we do this? We have now cosine and sine. So medyo complicated na siya, no? So remember your differential calculus as I've said earlier. So may mga tinuro ako sa inyo kanina, the antiderivative and the derivative. So now, do you remember your differential calculus? When we derive sine 2 theta, what is this equal to? So remember that sine theta, the derivative of sine theta and differential calculus is cosine theta. So now, this is similar to that. The only difference is that we have 2 here, but that is still the same. If we write sine 2 theta, we will also get cosine 2 theta, because this is the angle, that is the angle. So therefore, we know now that the derivative of sine theta is cosine theta. So now we can use the du over u formula. Let me see my okay. So right now, since we have 3 here, so this problem I've categorized this as difficult, since if you don't know your differential calculus, the derivative of the trigonometric functions, then you won't be able to answer this. This is a tricky one if you're a first timer. Remember that. So therefore, now let's move to our next step. So always remember we have 1 here, the top. If you don't have you don't see any constant at the top or coefficient, so there is always one present there. So now we have 1/3. So i-move lang natin siya sa labas. Now we will get 1/3 the antiderivative of cosine 2 theta over sine 2 theta d theta. So now, what's our next step? So since hindi pa naman siya nasa form ng dx over x, so we will use u substitution technique. So we will let u our sine 2 theta. So the derivative of sine 2 theta is equal to cosine 2 theta, right? D theta. Now isolate d theta, we will get du over cosine 2 theta. Now, let us substitute the value of du here. Let me erase this. Be sure to take note of what I am writing down so that you can catch up. So now we will have 1/3, since this is cosine 2 theta, and since we have our sine theta here, sine 2 theta is u, right? Let u sine 2 theta. So we will now put u here. So we let d theta is equal to du over cosine 2 theta. So now, if we multiply this, so that this will cancel out. Now what will be left will be 1/3 the antiderivative of du over u. So now this is in the form of our formula, which is the ln x plus c. 1 over x dx is equal to ln x plus c. So just substitute the value of du over u or dx over x. This will become, move this inside, we will have 1/3. Since we have to multiply this, we will now put next to that the ln u plus c. So is this our final answer? No, not yet. Since we have a value of u which is the sine theta. The value of u which is the sine theta. Now we will have our final answer as 1/3 ln the absolute value of sine 2 theta plus c. So this is our answer for our problem number 3. Now let us move on to our problem number 4. Just erase this. Now, our problem number 4. We have, just make this smaller since this is longer to solve now. 4x plus 2 over x plus 1 dx. So now, how do we integrate this? We have no formula for this, right? We doesn't have formula for that. So, ang gagawin natin, remember that integral calculus has a relation to all of your lessons when you were first here, right? Or when you are studying in first semester of your engineering program. So that is when algebra, this is when algebra will be used. So remember that if the exponent of the numerator is bigger than the denominator, we will now use the synthetic division, which is we divide x plus 1. We will use the synthetic division, x squared plus 4x plus 2. Since the exponent of our numerator is bigger than the exponent of the denominator, so now let us divide. So what do we have to multiply to get x squared? So we will multiply that by x, so that if we multiply this back here, we will get x squared plus x. So now there is a subtraction sign here. So if we subtract that, we will get 0, right? So this will become minus, then this will become 3x, right? So now next we will multiply that by 3. So we'll add here plus 3. So 3 times x, we have 3x. 3 times 1, we have, let's put this down, bring this down. 3 plus 1 is equal to 3. So now this will cancel out, so this will become negative 1. So answer correct. Okay. We just see if I am right. Since we can't be wrong in this kind of thing. Wait, I guess, okay, I've seen it now. I guess we are right. So now this will become, since we have here x plus 3, we will now write our new function. So we will change that as the antiderivative, since we've already divided using synthetic division. So this here, x plus 3, since we have a remainder negative 1, we will minus that to 1 over this, the denominator, x plus 1 dx. Now we have our new set of function. We just paste this. We have our new set of function. Which is this, the antiderivative of x plus 5 minus 1 over x plus 1. So now we just have to integrate this one by one. So if we integrate the antiderivative of x plus 5 minus 1 over x plus 1, if we integrate this x, this will become 1/2 x squared. Then this will become, the antiderivative of 5 is 5x, become 5x. Then if we integrate this, the 1 over x plus 1, this is in the form of du over u. Therefore our u will be x plus 1, then our du will, since this has a du here, our du is equal to 1 dx. Therefore dx is equal to du. So we just have to substitute this as du. Then this will become du over u. So du over u is just equal to ln u plus c. So this will become like minus ln. So our u is x plus 1. So it becomes the absolute value of x plus 1 plus c. So this is our final answer for the number 4. So now, since we are done with our problem number 4, we will now move to our problem number 5. So remember what I have taught you. So remember the process, guys. Just erase this. So now we will move forward to our problem number 5. So our problem number 5, that is the antiderivative of 8x over x plus 2 squared dx. So now if we let u is equals to x plus 2, so this will become u is equal to x plus 2, then our du, which is the derivative of this function, this will become 1 dx, right? So therefore this will become we write this in a new form. This will become the antiderivative of 8x over u squared, since we didn't integrate this squared here. So we just have to copy that, then dx will become du. So now this will become 8, the antiderivative of 8x over u squared du. So now since we still have an x here, and our goal is to remove all the x variables, so as you can see in this equation, we have x here. So if we transpose 2 to the outside, this will become x is equal to u minus 2. Now we have a value already of x, so we just have to substitute that. So now this will become the antiderivative of 8 u minus 2 d u squared du. So now we have to, let me just erase this now. Now we have to distribute 8 to this, the inside of the parentheses. So now this will become the antiderivative of 8u minus 16 over u squared du. So now we just have to integrate that one by one. Let me now erase this. We just have to integrate this one by one. So this will become, since both of them has the same denominator, this will become 8u over u squared. Then this will become minus the antiderivative of 16 u squared du, also has du here. So now we have to integrate this first part. So this will become the antiderivative of what? So we just have to move that 8 outside of our integral sign. So this will become u over u squared du. So if we divide this will become 8 1 over u du. So now this is in the form of the logarithmic formula. So this will become now 8 ln. So we have a value of u, which is x plus 2. This will become 8 ln, the absolute value of x plus 2. So we don't need to put plus c yet, since we still have our second part to integrate. Now let me just erase this. So our second part that we need to integrate is the antiderivative of 16 minus, there's a minus here, so 16 u du. So if we move 16, so this is u squared. If we move 16 outside, this will become negative 16, the antiderivative of 1 over u u squared du. So now since our denominator, which is the u, has a power of 2, we can apply the logarithmic formula. So now what we should do is move this u squared up. So now this will become negative 16. Wait. So this will become negative 16. The antiderivative of, we have u raised to negative 2, since we already move u squared to the numerator. So the exponent will now become negative 2. So next, wait, let me just erase this. So we just this 16 u squared du negative 16 1 over u squared du. Then this will become negative 16, antiderivative of u raised to negative 2 du. So now since we have a negative 2 here, so this will become, if we apply the power rule, this will become negative 16, the antiderivative of u, negative 2 plus 1 over negative 2 plus 1 du. So now, we just have to, no, we have to erase. This will now become that. So we have to remove this now. This will begin. So now, what we have only left is this. So this will become negative 16 times, this will become u, negative 1 over negative 1. So this will cancel out, this will cancel out. So what will be left is, what will be left will, this will become 16 times. So we have to move this to the denominator, since this one here has a negative exponent, so this will become 1 over u. So that's 16. This will become 16 over u. So our u is x plus 2. So now this will become 16 over x plus 2. So plus c. So if we combine this, the 8 ln, the absolute value of x plus 2, so this will become 8 ln, the absolute value of x plus 2, then plus, since this is positive, 16 over x plus 2 plus c. So now this is our final answer for number 5. So that is all for our topic 1, logarithmic integration. So now let us move on to our second problem, which is cosine, the antiderivative of cosine cube x dx. So how do we do this? So first is, kailangan nating ihiwalay ang isang cosine. So of course this will become cosine squared x times cosine x dx. So why? Because by separating, we can get the identities of this, right? We have an identity of this. So if we substitute the identity of this, I think this is doable now. We can integrate that. So what is the identity of cosine squared x? So cosine squared x, we can get that, or we can substitute that as the antiderivative of 1 minus sine squared x from the Pythagorean identities dx, from the Pythagorean identities. So now we have to distribute these. No, I think we will now use u substitution. Alright, okay. So we will use u substitution. We will let our u is equal to sine x. Sine x. So because if we derive sine x, this will result to cosine x. So if we plug in, if we isolate dx, this will become du over cosine x. So if we substitute the value of dx here, so this and this cosine x will cancel out. So what will be left will become, this will become 1 minus u squared, since we only let sine x our u. Therefore, mayroon pa tayong power of 2. So since cancel out na, wala nang cosine, du na lang matitira dito. So now we have our new set of function. So we have to separate this now, integrate separately. So what is the, so this will become 1 dx antiderivative of 1 dx minus the antiderivative of u squared du, no, du, this e. So this will become, since we only have 1 here, this will become u. We have to erase this. So now we have our the antiderivative of our first part. To integrate this second part, we have to use the power rule, right? So now this will become 1/3 using power rule, u cube. So is this our final answer? No, we will of course substitute the value of u in our answer. So now this will become sine x minus 1/3 sine cube x. So that's our final answer for problem number 2. I guess you've get that right. So now let's move to our problem number 3. So I hope you're catching up, since we are getting faster and faster.
Go.
Now let us move on to our third problem. We have cosine 4x sine 2x cos x dx. So at first this might seem like a hard one, but as we go on, this will become an easy one. So we are here now. So now let us integrate. So what do we do? So we know, since we have a cosine 4x here, cosine raised to 4, so we have identities for cosine squared. So now we will let this become cosine squared x raised to 2. That's still the same, cosine 4x. So this will now become sine 2x. Just copy this and this, cos x dx. So we have an identity for this. So we will use 1 minus sine squared x. We have a square here, then sine squared x cos x dx. So the only thing that makes this hard is the long process. We became vulnerable to mistakes. That's why this is a hard problem. So now, since we have 2 sine here and we have a cosine here, what do you see? So if we use u substitution, we let u is equal to sine x. The derivative of this is cosine. Therefore, if we isolate dx here, we got du over cosine x. So we can now, if we substitute this in here, we can cancel this out. So now we have our new function. We can write this now as like this: 1 minus u, since we let sine x our u, so this will become u squared, then this will become, we have sine here, then multiplied by u squared. So now what do we do? Of course, let us remove this, since it's not gonna be applicable now. Now, if we distribute this here, we will get u squared minus u to the fourth. So, du. So now, we just have to integrate that one by one. So, what is our u? So, but first, let us use first the power rule formula. So, if we use power rule formula, this will become 1/3. Since this we had 1 here, so power rule formula, we divide it by n plus 1. So, that's why this becomes like 1/3 times u cube minus this will become 1/5 u to the 5th power. So plus c. So now we just have to substitute the value of u to our problem. Wait, I guess I made a mistake. Wait, this still has. Wait. I forgot to plug in the squared here. Sorry. Made a mistake again. So this will now become. If we expand this will become 1 minus. We expand that 2u squared, since negative u squared minus negative u squared is negative 2u squared plus positive negative u squared times negative u squared is positive u to the fourth. The derivative, then multiply this by u squared. So we still have to multiply that. This will become u squared minus 2u to the fourth power plus what? U to the 6th, right? So if we integrate that one by one, this will now become, so use power rule formula, is now 1/3 u cube minus, since we have here 2, we move that out, we have, this will become, if we move this out, this will become 1/5 times u to the 5th power. So now move this back, we have 2. So multiply 2 to the 1/5, we will get 2/5 u to the 5th power plus here the 1/7 u to the 7th power. So now we just have to write that as a full. So wait, just erase this. So if you write this in a full form, so 1/3, wait, 1/3. So what is our u? Our u is sine. So now we will get sine cube x, then minus 2/5. Wait. 2/5 sine, since we have our u here, we have our u sine raised to 5x, we have 1/7, 1 plus 1/7, we have u here, sine raised to 7x. So that is our final answer for our problem number 3. So I hope you understand. So I apologize for the mistakes, but still we've got it right. So that's our final answer. Now, moving on to our fourth problem, we have this. Wait, our pentel pen, our marker. Now weak. So tangent raised to 5x. So how do we do this? So now we just have to separate also this by what? So this will be separated by tan 3x, since we know that we have an identity for tangent to x, tangent squared x dx. So that is why we've separated this into 2. So this will now become, so we have a identity for this, right? So this is equal to secant squared x minus 1. So if we write this, this will become tangent cube x times secant squared x minus 1 dx. So now we have to distribute this to what is in here. So this will become, we distribute that, we have tangent 3x secant squared x minus tangent x dx. So now we will now use substitution, since we know that tangent x is equal to secant squared x, right? If we let u, the derivative of tangent x is equal to secant squared x, right? Tangent x, then our du will become secant squared x. So therefore, this is in the form of a power rule, which is the x is to n dx, since this is the derivative of this. So that's in the form, right? So let us first integrate our first part. Erase this so that it gets messy. Now tangent x, so we will now get, since this is already in a form of power rule, u cube, this is u cube now dx. So this will become 1/4, if we use the power rule, 1/4 u to the 4. So we have our first part. We just write the answer here, 1/4 u to the 4. That is our first one. So now we have to integrate this second part, which is the negative tangent x dx. So now this will become our second part, negative tangent x dx. So as you've known, so wala tayong derivative of tangent x. No, we have one, which is sin x over cosine x, but I guess we cannot use that one. Oh, I made a mistake again. So tangent, that our function before, this is equal to, wait So it's equal to this, right? Tangent cube secant squared x tangent x secant squared x minus 1. So we are right for this part, but in here, in here, for when we distribute this into negative 1, we will get negative tangent cube x. So we still missing cube there. So now this is complete. So what can we do? So we have to separate it again to integrate. So this will become tangent squared x tangent x, since we have an identity for tangent squared x. So this will now become once again tangent squared x, tangent x only, tangent x secant squared x minus tangent x. As I have said earlier, tangent x, the identity of tangent x is equal to secant squared x minus 1. So if we distribute this to tangent, let me just get a new. If we distribute that to tangent x, so this will become tangent x secant squared x minus tangent x. So that is how we've got this. Just erase this. So now let's integrate this one by one once again. So let's remove this first to get a bigger space. So if we integrate this is also power rule. Since the derivative of tangent is secant squared x, so if we let tangent u become, this will become what? U, only u dx, I guess du, sorry, du, u du, that's in the form of u du. So if we use the power rule, this will become 1/2 u squared, since we've added 1 to the exponent. 1 plus 1, that's 2, over 1 plus 1, that's u squared over 2, or 1/2 times u squared. So now we have our second integration, second part. We still have a third part. So we have here, since we have negative here right earlier, so since we have negative tangent cube x, we still have that. We distribute this, we get a positive one here, I guess. Right. Okay. So this will become positive, right? Okay. So this will become negative in the form of 1/2 u squared. Then our last part, integrate our last part, integrate tangent tangent x. So how do we integrate that? So we know that tangent x is equal to tangent x is equal to sine x over cosine x, right? So sine x is equal to cosine x. So now we'll write that as sine x over sine x. Cos. If we let u is equal to cosine x, our du will become negative sine x, right? So dx, if we isolate dx, we will get dx will now become du. Dx will now become du over negative sine x. So if we substitute that to the dx here, since we have a dx here, substitute that, this and this will cancel out, the both sine x will cancel out. So since we have a negative sign, we'll just move that outside. This will now become negative. So therefore we will now, if we write that as new, this will become the antiderivative of, we have 1 over or du. Wait, can't write well. Du over u. So that's in the form of ln x. So what is our u? So we can write this now as ln u plus c. So having some time problem. So this is in the form of ln, wait, this is the form of ln u plus c. So our u is cosine, right? So we just have to substitute, then this will become negative ln I'm having some problem. Negative ln ln cosine of x plus c. So that is our final answer. The ln, absolute value of cosine x, absolute value of cosine x plus c. So this is our final answer. We have 1/4 u to the 4th power minus 1 minus 1/2 u squared minus ln cosine of x plus c. So that is our final answer. Now let's move on to our last problem, to trigonometric transformation. So our problem number 5 is the antiderivative of sine cube x 2 minus 3 cosine x squared dx. So how do we integrate this? So of course, first we have to separate this into becoming like this, sine squared x. So since squared here, magmumultiply pa tayo ng sine x, and copy this, 2 minus 3 cosine x raised to 2 dx. So now, so what do we do? So we have an identity of sine 2x. The identity of sine 2x is equal to 1 minus cosine squared x. Since here, if you put this here, this will complicate things. We have to move this here. So this will become 2 minus 3 cosine x, and moving that sine x here, this will become sine x dx. So now observe that if we let u our cosine x, then the derivative of cosine x is negative sine x. So this is the same here. So we now will let now u is equal to cosine x, so that we can cancel this out. So if we let cosine x or u, then the derivative of cosine x is negative sine x, right? So now if we isolate dx, this will become dx is equal to du over negative sine x. So if we substitute this dx here, we will now cancel this out, and we have a negative, we still have a negative left there. So now this will become our equation. We have to put negative outside our integral sign. Then this, the only thing that will be left is 1 minus cosine squared x, 2 minus 3 cosine of x. Wait, so this here has squared. We've already let cosine x or u, so let's replace this as u. Let me rewrite. So this will become u squared. So this, if we expand this, so this will become 2 times this 4 minus negative 3 cos x minus 3 cos x is 6 cosine x. Then 3 cos x times 3 cos x, so we become 9 cosine squared x, right? So wait, this is 12, since 2 times 3, yeah, 2 times 3, so 2 times 3 6 times, so 6 plus 6 is 12 cosine x. So since we've let our u cosine x, so let me just replace this again. This will become 12u squared, then plus 9u raised to 4. So we just erase this since we've already cancelled that out. So now we have this. So let's just distribute. So this will now become, erase this here. So this will now become 1 minus 1 times 4. So 1 times, have here 12u squared plus 9u raised to 4. Since we have this will become u raised to 2. So u squared, negative u squared times negative 12. We have positive 12 u raised to 4. Then last part, negative times positive 9, negative u squared times positive 9 raised to u raised to 4. You have 9 u raised to 6. So now combine like terms. So what do we have? What terms do we have? So this and this, and so this and this. So now okay, 5u squared, so you have squared. Wait, let me just so 12u plus 9u squared. I think I'm something wrong. So this is 12u only. Okay, sorry, I made a mistake again. So this is 12u, this is 9u, this to 2, this is u, since we have here u, 4u, this is 4u squared, 4 u squared, negative 4u squared, minus 12u cubed, then 9u raised to 4. So now we have this same term, that's the 9u squared minus 4u squared. So we have a still have a negative here. So this will become 4 minus 12u plus, so 9u minus 4u squared. So this will become 5u squared. This has a bigger coefficient. Then this just copy 12u raised to 3 plus 9u raised to 4. Now we have to integrate this one by one. So let me just write this here. So this will become negative 4 minus 12u plus 5u squared plus 12u cubed plus 9u raised to 4. So this raised. So if we integrate that one by one, our first, so this one, our first part, integrate that, the negative, so this will become negative 4, right? So this will become negative, so we have a du here. So we will have our first part, negative 4u. Since if we integrate this, this will become 4u. So next, if we integrate this will become positive, right? If we distribute here, so positive, this will become plus, since we have 12 here and 1/2, this will become 6, right? 12 divided by 2, 6u squared, become 6u squared. So this will become, since we have negative here, this will become positive here, this will become negative. Then 5, we have 5 here. Then if we integrate this, this will become 1/3 u cubed. So 1/3 times 5, this will become 5/3 u cubed. So next is this. If we integrate this, this will become 1/4 times u raised to 4. So 1/4 times 12, and we also have negative sign here. We have to use negative sign here. So 1/4 times 12, so this will become 12/4. So 12/4, we can divide that. So we will get 3. So we will now get 3u raised to 4 plus our last one, no, minus. Since we have a negative here and positive here, so 9/5, that's 9/5, since 1/5 times 9, u to the 5th. So now this is not yet our final answer, since we have to substitute the value of u here. So our u, what is that? So our u is cosine x, right? So we substitute that, we will get negative 4 cosine x plus 6 cosine squared x minus 5 over 3 cosine cube x minus 3 cosine 4 raised to 4x minus 9 over 5 cosine 5x. So is this right? Let me just, okay, that's right. So we have 9u here if we derive that. Okay, this is our final answer for this problem. So I hope you get that one. So now we are done with our topic 2. So I guess we will now move on to our topic 3, the inverse trigonometric transformation. So now let's move on to our topic 3, which is the inverse topic 3, which is the inverse trigonometric integration. So let me just remove this. Inverse trigonometric integration. So inverse trigonometric integration, we have two formulas that we will gonna be using. So first one is this, we have the antiderivative of du over square root of a squared minus u squared. This is equal to arc sine u over a plus c. So this is the u here and this is our a. So that's our formula for arc sine. So if we encounter this kind of function in this form, a function that is in this form, so we just have to use this one, substitute the answer to this. So that is our formula for arc sine. Now moving to our second formula, the du, the antiderivative of du over a squared plus u squared. So now if we encounter this kind of function, form of function, so that is equal to 1 over a arctan u over a plus c. So this a here is the a here. So it is not the same as to our, what's this, our formula number 3 earlier. So this is the a in here, not the derivative of this denominator. So remember this formula, as our problem will only revolve in these two formula. So there are other formulas out there like the arc secant, but we will not be using that formula here in our problems. So let me just remove that. So now let's start with our problem number 1. So what do we have here? Just here. So our problem number 1, we have the antiderivative of dv over 9 plus 4v squared. So how do we solve this? So as you can see, our function is in the form of arctangent. The only difference is that we have our u is 4v and our a here is only 9. So how can we convert this to a squared plus u squared? So if we let u squared is equal to 9, then if we square root both sides, so this will cancel out, our u will become, no, this is a squared. If we let a squared is equal to 9, then square root both sides, then our a will become 3. So now this will become dv over 3 squared. Since if we squared this will result to 9 also. So plus, we let u squared is equals to 4v squared. Now, kung square root natin yan, magiging cancel out yan, cancel out, magiging, so u is equal to, so syempre may square root yung 4, so this will become 2v. So now we will now change this as 2v raised to 2. Since if we distribute this power here, power of 2, this will become 4, this will become v squared. That is still the same. So now we have our new function that is in the form of arctangent. So what do we do? So I think okay, right. So this is in the form of arctangent. Now we just have to use this. So this will now become 1 over, what is our a? Our a is not 9, our a is 3. So we will get 1/3 arctangent. What is our u? Our u is 2v over our a is 3. So plus c, this we lock. Arctan, our answer is this. Simple as that. You just have to remember the formula and familiarize how it looks like. So that's it for our problem number 1. So proceeding to problem number 2, we have the antiderivative of dz over z squared, wait, so it looks like a z, plus 6z plus 10. So as you can see, this is also in the form of arctangent since we don't have a square root. So this we can only choose between these two. So as you can see, this already looks like the arctangent, but we have 3 terms here. So what do we do? So of course we need to factor that out, but as you can see, the factor of 10 is 2 times 5 and 1 times 10. So if we add 2 plus 5, that is not equal to 6. Then if we add 10 plus 1, that is not also equal to 6. So what do we do? So as you can see, okay, we can do it like this. We can, so dz over So if we make it plus 6z plus 9 plus 1, that is still equal to 10, right? But as you can see now, we can factor this out now. The z squared plus 6z plus 9, since that is a perfect square. So if we factor this out, this will become dz over, so what's the factor of 9? That is 3 times 3. And if we add 3 and 3, we will get 6. So therefore we have to write it as z plus 3 squared plus 1. So now malapit na tayo sa katotohanan. So as you can see, we have already a u squared here. So this represent a u squared. So and this is our a. But take note that if i-squared natin ang 1, that is still 1. So therefore we can count this as already arctan. So now we just have to use the arctan formula. So substitute, we will now get 1 over, what is our a? 1 over 1, then arctan z, since this is our u, we have a formula, arctan u over a, z plus 3, z plus 1, I mean, over 1, then plus c. So this will now become arctan z plus 3 plus c. So that is our final answer for the number 2. So I hope you get my point. Let's get moving to problem number 3, since we've already answered number 2. Now moving on, our problem number 3 is this 3. So, antiderivative of e raised to 4x dx over square root of 16 minus 4 e raised to 8x. So as you can see, there's a square root. Therefore, ang kalalabasan nito ay arcsine. But hindi tugma ang mga value ito dito. We have an e raised to 4x at the top, then we have an 8x, then 16. So how do we do that? How do we convert this to become in a form of the arcsine? So of course we will use u substitution. So if we use u substitution, and if we let u is equals to e raised to 4x, now du will become 4e raised to 4x dx. So if, as you can see, we have a e 4x dx, then we have here e 4x dx. So if we isolate this, we will get e raised to 4x dx is equal to du over 4. Now we have a value of this already, so we can substitute the value of this here. So now substitute. We now have du over, over 4 over square root of 16 minus 4. We can let this here u, since we have e raised to 8x, so we have our u e raised to 4x. So if we squared this, e raised to 4x times squared, this will become e raised to 4x times 2. So e raised to 4x times 2, this will become e raised to 4x times 2 if we squared this u. So that will become 8x. So that's still the same. So just let me erase this. So now we have this here. So if we move the 1/4 here outside, we will get 1 over 4 the antiderivative of du. So as you can see, okay, if we get 4 out, we will now if we shrink this will become 4 times 4 minus u squared, right? So if we square root 4, this will become 2 only now. So we'll remove that now. So we have a 1 here, right? A 1 in that next to the du. So now we will multiply 1/4 times 1/2, we will get 1/8, right? So we'll just write 1/8. Now we have du over the square root of, so since this is 4, we can also write that as 2 squared minus u squared. So now this now is in the form of arc sine. So we just have to substitute the value. So let me erase this. I guess you already understand that. So this is already in the form of arc sine. So we just have to have 1/8 here, and then we can do this as, okay, multiply this, multiply it by arc sine. So this is arc sine. So since we have our u as e raised to 4x, so we will let that as e raised to 4x over our a is 2, so this will become plus c. So this is our final answer. Just as simple as that. You just have to widen your mind and see the picture of that. So I guess we're done with problem number 3. Now let's move on to our problem number 4. So our problem number 4 is the antiderivative of dq. We have the dq over square root of, let me just move this to the middle part, dq over square root of 15 plus 4q minus 4q squared. So what do we do? So now we have to align first or reorder. So this will become, if we reorder this will now become, we just reorder, this will become negative 4q. Just get another pen. For negative 4q squared plus 4q plus 15. That is the ordered form. So now, what do we do to factor this out? So we need to factor this out. We know that this is in the form of arc sine since there is a square root. So to factor this out, let square root of, so the negative 4, we move it outside, so then multiply q squared minus q, since if we distribute this will become positive for q, then this will become negative 15 over 4, so that if we distribute this here, this will become positive and the 4 will cancel out. So that is our factored form. So now let us complete the square in q squared minus q. So if we complete the square, this will now become dq square root of negative 4 multiplied by the quantity of q minus 1/2 squared minus 16 over 4. So why is it that it became like this? So if we expand this will become q squared. This will become q squared. Then this will become negative q squared, then negative q. Then the only thing that has been added is the positive 1/4. So since if we square this 1/2, then this will become positive 1/4. So why did our 15 over 4 become 16 over 4? Since we have 1/4 here, right? If we expand this, we will get 1/4 here. So therefore 1/4 minus 16 over 4 is just equivalent to 15 over 4. So that is our factored form now. So now if we expand this, so if we distribute this 4, now that is equal to dq over negative 4q minus negative 4q times, what's this? This will become negative 4q times the quantity of q minus 1/2, right? Minus 16 plus 16, I mean. So therefore, if we move if we squared 4 again outside, this will become 2 square. If we square root 4, this will become 2 square root of negative q minus 1/2 squared plus 4. Since if we move this inside, this will become 4, right? Then if we multiply this in these two terms, here, then that will become negative 4q, negative 4 times q minus 1 half squared plus 16. Right, so now we have this factored form. So if we move this 1 half outside, this will become dq over square root of q, negative q, wait, negative quantity of q minus 1 half squared plus 2 squared, since 2 squared is equal to 4. So now this is in the form of what? The arc sine. So our final answer would be, since we still have 1 half here, so that will become 1 half, our final answer, 1 half arc sine, since we have our u is q minus 1 half over 2 plus c. So this is our final answer, but we can still simplify that, since if we get the LCD of this u here, we will get 1 half arc sine. So this will become 2q minus 1 over 4 plus c. So this and this is just the same. So you can answer it with just this, or you can answer this with also this form. So remember that. So that is our final answer for problem number 4. So now we will now move to our final problem for the inverse trigonometric integration, or problem number 5. So this one here is a long one, I guess, since we have a long function. So number 6, we have the antiderivative of 6 sine theta minus 12 cosine theta d theta over 9 sine squared theta plus 16. So now the first thing we should do is distribute this cosine theta here on what's inside the parenthesis. So we will now get the antiderivative. Let me just erase this. Antiderivative of 6 sine theta cosine theta, since we've distributed cosine theta minus 12 cosine theta d theta over 9 sine squared theta plus 16. So now we will now use the u substitution technique. So we will let our u is equal to sine theta. Since we derive sine theta, we will get cosine theta d theta. Then if we isolate d theta, we will get du over cosine theta. So now if we substitute the value of d theta here, so this will cancel out, this will cancel out, and this will cancel out, since we will now distribute this theta d theta here. So from what we are left now will be this will become the antiderivative of 6, since we've let sine theta or u u 6u 6u minus 12 over 9u squared plus 16 du. So this is our new function. So what should we do? Of course, we will now, let's erase this first. So we're already done here. We will now integrate this separately. So first, let's integrate this part. So we have the antiderivative of 6u over 9u squared plus 16. So if we let u is equal to, since we have our du, u is equal to 9u squared, so we will get du is equal to 18u du. So that's the same. So isolate du, that's still the same. Du will now become du over 18u. This will become what? We isolate du. This will become 6u, then du over 18u over, since we've let 9u plus 16, I guess we'll add plus 16 here, since 16 is 0 if we derive that. So therefore we will now get only u here. So this will become u. So now this will cancel out, this will cancel out, and 6 over 18, that is equivalent to 1/2, 1/3, I mean 1/3, that is equivalent to 1/3. So now we have 1/3 du over u. So since we have du over u, this will become 1/3 ln, since our u is 9u squared plus 16, 9, since our u, we still have a value of our u, which is sine, 9 sine squared theta plus 16. So that is our first part. Let me just write this here. So our first part would be 1/3 ln 9 sine squared theta plus 16. So we won't be putting plus c yet, since we still have our second part to derive. So our second one to derive will be the antiderivative of negative, since we have negative here, 12 over 9u squared plus 16 du. So this here looks like the arctan formula. So what do we do? Of course, we just have to factor this out. So let's move out 12 first outside. Negative 12 become negative 12. The antiderivative of du over 9, will move 9 outside. So 9, since this is not a perfect square, so 9, so become u squared, then plus 16 over 9, so become 16 over 9. So our next thing to do would to move out would be to move 1 over 9 outside. So Negative 12 times 1 over 9, this will become negative 12 over 9. Antiderivative of du over u squared. So this will become plus. We can multiply this by what? So 16 4. This will become 4/3. Since if we squared this will become 16 and this will become 9. So now we have our new set of function. So now this now looks like the arctan formula. So we just have to substitute. So first copy this 12 over 9. 12 over 9. So this is also equal to, we multiply that by 3 over 3, equal to 4/3, negative 4/3. So now this will become arctan. So since we have 1 over a here, multiply that by 1 over a, 1 over 4/3. This will become 3/4. This will become 3/4. Since we'll move 3 to the numerator. Just make this here. So this will become 3/4. Now just put arctan. Wait. This will become arc. Let me change my pen. This will become arctangent of u over a. So what is our u? So our u is sine. We have sine theta. Our u is sine theta over 4/3 plus c. So now this will become cancel 3, cancel 4. This will become negative. Is equal to negative arctangent of 3 sine theta over 4. Since we will move this 3 up, then that plus c. That is now our final answer. So that is all for topic 3. That's all our problem. Now for our final topic, we have the integration by parts. So we will now move on to our final topic. So let me just erase all of this. So we have topic 5, 4 I mean, topic 4, the integration by parts. Integration by parts. So now we have our last topic, the integration by parts. So there is a formula in integration by parts, by the way. This formula is helpful in solving problems under this topic. So this formula is very exclusive to the integration by parts. So the integration by parts is developed so that we can solve difficult problems. We can integrate difficult problems. So these problems here are the difficult one to integrate. that's why the integration by parts is formulated. So this integration by parts formula is derived from the formula of the product rule differential calculus. So you remember, right, the product rule in the differential calculus, right? So product rule in differential calculus goes like this: the uv, derivative of uv is equal to what? Derivative of uv is equals to udv plus vdu. That is how the product rule in differential calculus is done, right? So if we integrate all of this will cancel out. Therefore, we will now have uv is equal to the antiderivative of udv plus the antiderivative of vdu. Now, if you move this here, we will now get the antiderivative of vdu, udv, is equal to uv, which is this, minus, since we've moved this there, now this will become negative sign, so minus v du. So that is how we've got this formula for the integration by parts. So now, since we've understand where did the formula came from, we will now already solve our problem number 1. So wait a second. Our problem number 1. So our problem number 1 is the antiderivative of x squared ex dx. So if we use the formula udv is equals to uv minus the antiderivative of vdu, so this here is in the form of udv, so therefore we'll just be using this. So our u, so of course you must pick which of these two is the one you're going to integrate and the one you're going to differentiate. So there is a method in picking which one to differentiate first. So there's a the Liate method of choosing. So first one that we should derive is the logarithm. Second is the inverse. Third, we have the algebraic. And fourth, we have trigonometric. And fifth is the exponent. So that's the order of which we should derive first. So as you can see, we have x squared e raised to x. So in Liate method, algebraic came first. So therefore, we will be differentiating the x squared. Therefore, we will get u is equal to x squared. If we derive that, this will become du is equals to 2x. Then we integrate, this will become dv. That's the form of different. If integrating e raised to x, then if we integrate that, v will become e raised to x. It's still the same, e raised to x. Since if we integrate e raised to x, that's still e raised to x. That's the same if we differentiate e raised to x, that is still e raised to x. So now what should we do? Just follow the format of this formula. So uv, what is our u? We have x squared. V, we have e raised to x minus the antiderivative of v. What's our v? E raised to x. Then du, we have 2x dx. So now we still have to integrate this, because this can still be integrated. So if integrate that, this will become negative. So uv, we have, this will become our u. Excuse me. This will become, our u is 2x, our du will become 2, then our dv is e raised to x, our v is still e raised to x. So we'll just have to erase this. So now this will become negative uv. Our u is 2x e raised to x, since v is e raised to x, minus antiderivative of what? V du. We have v e raised to x, then 2 dx. So now we have this x squared e raised to x minus 2x e raised to x plus, we have ex 2 dx. So we still have to integrate this, since it can still be integrated. So what do? We let u is equals to 2, then the derivative of a constant is 0. So u is equals to 2, du is equals to 0. Now dv is equals to e raised to x, and v is equals to still e raised to x. So what's the next step? Of course, input it in the formula. So we will get, since we have positive here, we'll get what? So uv, u2 times ex, we'll get 2ex. So that's our first type, 2ex. So next, the minus the antiderivative of v du. So our v is e raised to x, but since our du is equal to 0, then this is 0, so we don't have to integrate anymore. So let's just substitute 2x here, then our final answer would be this 2. Our final answer is this. So that is how you perform the integration by parts using its formula. So aside from that, there is still another method that we can use to solve this kind of problem. We can solve this using the tabular method, which is you identify which part should be differentiated and integrated. So we know the Liati method on choosing which should be differentiated. So we should differentiate x squared, right, since it's in the algebraic, and we should integrate e raised to x. So in tabular method, we put plus minus at the side. So this is because if in integration by parts, we continue to change the operation since the since what do we call this, so since this accounts for the sign changes that occur during repeated integration. So since we are integrating repeatedly, so this here is an alternating one, so we account for the sign changes. So therefore, if we differentiate this, we will get first 2x, wait, just switch, we got 2x. Then if we differentiate 2x, we will get 2. We differentiate 2, we'll get 0. So if we integrate e raised to x, that is still e raised to x, then still e raised to x. We just switch. So e raised to x, e raised to x, e raised to x, x here, e here. So how do we perform this tabular method? So we just have to multiply this here, then multiply this here, multiply this here, and the last part is the one to be integrated. That's how we perform this tabular method. As you can see, this is much easier, right? So now what do we have to do? So if we multiply this, we'll get x squared e raised to x. Since this is negative, we'll get minus 2x e raised to x. This is positive, plus 2 e raised to x. Since if we integrate this is still 0. Since 0 times e raised to x is still 0. So we just don't need to put that, but we have to add c at the end. So that's how we perform the tabular method. Much easier from this, right? So that is our final answer for number 1. So now let's move to problem number 2. So as of from now on, we'll be using the tabular method to get our answer fast. So our second problem, we have ln x dx. So as you can see, we don't have another function here, so we just only have one function. So how can we integrate this using integration by parts? So the Liate method suggests that the first one to be differentiated would be the logarithm. So let's write this first. The logarithm. So ln x. Then what should we integrate now, since we don't have another function? So as you can imagine, this one has always 1 here. So therefore, if we integrate 1, what should we get? That is x, right? Then this will become, if we differentiate this this will become 1 over x, right? So is this how we stop? Yes, we should stop here now. So we will now stop here to identify first if because you can see if we integrate this one, it is doable, right? So therefore we will now stop here since we can integrate this one. So you must know how or when to stop when differentiating and integrating using the tabular method. So now what do? We will now multiply this. We will get, multiplying that, we will get x ln x. So we multiply that, so minus the antiderivative of x 1 over x dx. So as you can see, this will cancel out. What will be left is x ln x minus the antiderivative of 1 dx. So this is just equal to x ln x. So if you integrate that, then the integral of 1 is x. So our final answer would be x ln x plus minus x plus c. So this is our final answer for number 2. So you should be able to imagine things so that you can integrate, or you can see or picture out the solution that will be needed. So that is how we do the problem number 2. So now let's move to problem number 3. So problem number 3, the antiderivative of e raised to 4y cos 5y dy. So using the Liate method, exponent is in the last part, so therefore we will be differentiating the cosine 5y. So minus plus. So cosine 5y, if we differentiate that or derive that, we will get 5. So what's the derivative of cosine? Negative sign, right? So negative sign 5y. So then if we integrate, we have e4y. So as what we have what I have explained from the first part of the video, the formula of e raised to 4y, this will become 1 over a, which is the derivative of this, which is 4. 1 over 4 e raised to 4y. So that's the integration of e raised to 4y. Now next, why do we have to still continue? Because if we integrate this, it's not doable. And also, as you can see, if we still integrate this one, this will become 5. So 25. Why? Right? 25. This will become 25. The sign, negative sign, is equal to negative cosine, right? So this will become negative cosine. Wait, let me just see. I am right. So this will negative cosine. This will become negative cosine, since that's negative sign, 5y. So what's the integration of 1 raised to 1 over 4 e raised to 4y? So just have to derive this again. 1 over 4 times 1 over 4, that's 1 over 16, right? 1 over 16 e just e raised to 4y. So that is how we integrate this e raised to 4y. So now, as you can see, this one that we should integrate looks the same as this one. The difference is the only difference is the coefficient around them. So therefore, we have to stop now. So multiply this part, multiply this with this part, and integrate this part. Okay. So just let this e raised to 4y be here. So don't touch this e raised to 4y. So now we will get 1 over 4 cos 5y. Wait, 1 over 4. This will become 1 over 4 e 4y cos 5y. Since this is negative and this is negative, that will become positive. So plus 1 over 16 e 4y times 5 sine 5y. So this will become 1 over 16 times 5. So this will become 5 here. 5 over 16. 5 over 16 e 4y sine 5y. So right, let me just write this one. So up to 1 over 4 e 4y cos 5y, then plus 5 over 16 e 4y sine 5y plus this one. So this will be minus, right? This will become minus since we have a negative sign here. So 25 over 16, we will get 25 over 16 e 4y cosine 5y dy. So as you can notice, this here is similar to our original equation. The only difference is that the coefficient. So now we have to, as you know, our formula is this udv, right? The integral of udv is equal to uv minus the integral of v du. So therefore, we still have here, we have to put this in our equation, since we have a similar one of this here. So now we will get the antiderivative of e raised to 4y cosine 5y dy. Wait, cosine 5y dy. So let me just erase this since we're already done with this. So now we have to combine like terms. So if we combine this will become add, right? So now this will become the antiderivative of e raised to 4y cos 5y dy plus the 20 plus 25 over 16 antiderivative of e 4y cos 5y is equal to what? We have 1/4 e 4y cos 5y plus 5 over 16 e 4y cos sin 5y. So let me trace this now. We have this now, right? So since this is a similar term and we know that this has a 1 in here, so now we can add like terms. So 25 plus 25 over 16 plus 1, we have 41 over 16, right? So we will get 41 over 16 e 4y cos 5y. So I hope you can still see my writings since my pencil is now dying. My marker is now dying. Now we have this now is equal to 1/4 e 4y e 4y. Wow. Wait, let me just write 1/4 e 4y is still not working. We have 1/4 e raised to 4y cosine 5y plus 5 over 16 sine 5y. So to get this back to our original equation, we have to multiply both sides by 16 over 41 so that we could cancel this out. This will be multiplied to 16 over 41. So now this will become antiderivative 4y of e 4y cos 5y is equal to 16 over 41 times 1/4. So 16 over 41 times 1/4. So what do we have? We will get 4. Just write this down. We have 4 over 41 e 4y cosine 5y, then 16 over 41 times 5 over 16 will cancel out, then we will get plus 5 over 41 sine 5y. No, we still have e 4y. Wait, we put e 4y here. Sine 5y. So e 4y sine 5y. So now we have that. So our final answer will become like this: 1 over 41 e for y. So we need to move 1 over 41 e for y outside, or we need to factor this out. For y times, so we can, since we have here 4, so we will put 4 as a coefficient of cosine 5y, so that if we multiply this back, this will result to 4 over 41 e 4y cos 5y. Now next is this. Wait, let me just plus, what do we have? Plus 5. So now we will get 5 here, put 5 as a coefficient of sine 5y. Then always don't forget the plus c at the end. So this is now our final answer. 1 over 41 e raised to 4y times 4 cosine 5y plus 5 sine 5y, then plus c at the end. So that is how we solve this problem. That is problem number 3. So we still have 2 more problems to solve. So now let's move on to our problem number 4 to get this done already. Now, so now let us move on to our problem number 4. So what do we have here? Number 4, we have the antiderivative of secant cube theta d theta. So how do we integrate this using the tabular method? So of course we have to separate. We will now have the antiderivative of secant squared theta secant theta d theta. So now we now have this tabular method di. So since both are trigonometric, you just have to think kung alin sa kanila ang mas madaling i-integrate at i-differentiate. So among these two, the easiest one to integrate is this secant squared theta, because if we integrate secant squared theta, that is just equal to tangent. Therefore, if we integrate secant squared theta, that is just equal to tangent theta. Now, if we differentiate secant theta, that is also easy one to differentiate, because that is just equal to secant theta tangent theta. So now, do we have to stop here? So as you can see, if we integrate this, if we multiply this is equal to secant theta tangent squared theta. So if we integrate this, distribute, if we let tangent squared theta become secant squared theta, look, just like this. This will become secant theta tangent squared theta, right? So now, using the trigonometric substitution, what's the identity of tangent squared theta? This will become secant squared theta minus 1. So if we distribute secant theta to secant squared theta, that is the same as the secant cube theta. So now we have a similar one to our original equation. So now we have to stop here. since we have a similar one already. So multiply this into this, then integrate this part. So now we will get secant theta tangent theta is equal to what? Let me see. Minus. So let me just erase this. Let's put this here. You have secant theta tangent theta minus, you have the antiderivative of secant theta tangent theta squared. So if we use the trigonometric substitution or trigonometric transformation, this will become secant theta tangent theta minus secant theta. This will become secant squared theta minus 1. So d theta. So this will become secant theta tangent theta minus secant cube theta, the antiderivative of secant cube theta, minus the antiderivative of secant theta, since secant theta times negative 1 is negative secant theta. So secant theta d theta. So now we have to input our original formula here. So this will become the antiderivative of secant cube theta d theta. So sa d theta here minus d theta. So what's the next step? Of course, combine like terms. If you move this to the front, we will get 2 secant cube, 2 the antiderivative of secant cube theta d theta is equal to secant theta tangent theta minus the antiderivative of secant theta d theta. So what is our next step? Of course, we have to multiply these both sides by 1/2 in order for this to get cancelled out. So multiply this by 1/2. So now this will become the antiderivative of secant cube theta. Okay, let me just divide this. The antiderivative of secant cube theta is equal to what? This is 1/2, since multiplied by 1/2 secant theta tangent theta minus, put 1/2 outside beside the integral sign, secant theta d theta. So now the only thing that is left is to derive, or to integrate this secant theta d theta. So let's erase this. Now what will this become? So if we integrate secant theta, so do you know that if we multiply, so wait, let me just write this still have ink. If we multiply secant theta d theta by secant theta plus tangent theta, tangent secant theta plus tangent theta d theta, so this is still equal to 1, right? Since secant theta plus tangent theta over secant theta plus tangent theta, just cancel, that is equal to 1. But that will now change as we distribute this to the top. So this will now become, so we have 1/2 here. So why did we choose to multiply that by secant theta plus tangent theta, not secant theta tangent theta? Since if we just put secant theta tangent theta, then if we distribute that to the top, then the top won't be the derivative of the bottom. So now if we distribute this secant theta to the top, so secant theta times secant theta is secant squared theta, which is the derivative of tangent theta. So here secant theta plus secant theta times tangent theta is equal to secant theta tangent theta, which is the derivative of secant theta. So that makes sense, right? Therefore this will now become the, wait, let me just this will now become the antiderivative of secant squared theta plus secant theta tangent theta over, just erase this one, so over secant theta plus tangent theta. So this is now in the form of logarithmic formula, right? Logarithmic integration. So du over u, since this here is the derivative of secant theta plus tangent theta. Since tangent theta is the derivative of tangent theta is secant theta, secant squared theta. So then we have secant theta, the derivative of secant theta is secant theta tangent theta. So now we have du over u. So this will now become ln, wait, we just, so now become ln so now become ln the absolute value of secant theta plus tangent theta, because we know that du over u is ln u plus c, right? That is ln u plus c, okay. Ln u. So therefore our u is secant theta plus tangent theta. So now we have the derivative of our third part. So now let's combine all to get our final answer. So our final answer will become, so since we have 1/2 secant theta tangent theta before and we have 1/2 here, so our answer will become just ln, no, 1 half secant theta so 1 half secant theta tangent theta one half secant theta tangent theta minus, since that is a negative sign before, right? Since that is negative secant theta, right? So minus, since we have a 1 half there, 1 half, our result for the derivative of the integration of secant theta, we have ln. So let me just change my pen. This is equal to minus 1 half, so this is 1 half, wait, I'm sorry, so let me just write this down. 1 half ln, so since we've got ln secant theta plus tangent theta, let's just plug this in our answer. Secant theta plus tangent theta plus c. So now this is 1 half. Okay. Wait. Let me just guess we're running out of ink. So we have 1 half ln. So our final answer is equal to 1 half secant theta tangent theta minus, we have a minus here, sign, 1 half ln, the absolute value of secant theta plus tangent theta plus c. So that is our final answer for problem number 4 using the tabular method. So now we'll be moving to our last problem. Now, moving on to our last problem, we have number 5. The antiderivative of ln x over 1 plus ln x. So, how do we integrate this using the tabular method? Since this is a quotient, right? This is a quotient. Just dy dx here. So, how should we integrate this? So this is done like this. So now we should differentiate ln x definitely, but we still have ln x here, and our goal is to integrate ln x, but ln x doesn't have an elementary integral. It's non-elementary integral, so we can't integrate that easily. So how should we do this? So let's just go with the flow. So let's make this 1 over 1 plus ln x squared. This is a squared here. So squared. So what should we do in order to integrate this? So we know that the derivative of ln x is equal to 1 over x. So what should we do? So we have 1 here, but we doesn't have an x. So what if we put an x here? Is this reasonable? Yes, it does. So we will now let u is equal to get the integral of this, to integrate this. U1 is equal to 1 plus ln x. So now we will derive that this will be equal to 1 over x. So now dx. So if we isolate this will become dx is equals to x du. This will become x du, right? This will become x du. X du. Wait, let me just make this clear. X of x du. So if we substitute this dx here, then we will now get this will cancel out. So now this will now become 1. This will now only become 1 over u squared, right? This will now become 1 over u squared du. So if we integrate 1 over u squared, this will now become what? It will now become negative 1 over u. Since we have to move that up, then this will become u raised to negative 1 over negative 1. Then if we move this down again, this will become negative 1 over u. So negative 1 over u. So that is how we this is our form when we integrate this here. So if we substitute u, we will get now the integral of this, which is equal to negative 1 over 1 plus ln x, right? So we have now 1 plus ln x. Then since we've added x here, we should add x here, so that if we add x here, this will cancel out because this is just equal to 1, right? Therefore we should add x beside ln x. So we will now, so if we derive that, we will get x times 1 over x plus we'll get ln x plus ln x. So now let me erase this part here. So now we multiply this here, we multiply this to this. Okay, wait, let me just, this will now become what? X, just make this here, x ln x over what? 1 plus ln x. So that is our first part. This is negative. Since we have here positive, this is negative, then we have here negative. So this will become negative x ln x 1 plus ln x. So if we integrate this will become plus, right? Since negative times negative is positive. So as you can see, this is equal to what? X. This will cancel out. Now what will be left is 1. So this is now 1 plus ln x. So 1 plus ln x times 1 over 1 plus ln x, this will cancel out this and this. So therefore, that will now only become the antiderivative of 1 dx, right? So this is now much easier to integrate. So if we integrate this now, x ln x over 1 plus ln x, this will become plus x, since the antiderivative of 1 is what? It is x, right? So now, is this our final answer? No, not yet. So we have to make their denominator the same. So this will now become, we have to multiply this by 1 plus ln x over 1 plus ln x. So this will become x ln x over 1 plus ln x plus x plus x ln x. So x ln x over 1 plus ln x. So since we have the same denominator, we have to combine them. So we will now get what? Negative x, wait, this is x minus x ln x plus x ln x over what? 1 plus ln x. So since this is like terms, so cancel out since they have different operations. Now this, our final answer will be equal to x over 1 plus ln x. So this is our final answer for problem number 5. So wait, let me just make my answer clear. X we have 1 plus ln x. So this is our final answer. So that is all for topic number 4. So now we are done with all the topics. So I hope that you have learned something from this video. So that is all. Thank you for watching and keep on.